I hope a resource person has joined. So let us start the session. So good evening to one and all. A warm welcome to all the dignitaries and all the teaching fraternity who has joined this session. Even after the working hours, thank you all of you for joining this session. As continuously you people are joining so regularly and punctually for joining our session. Thank you to everyone. So let us start the session, today's session. So to start the today's session, let us introduce our today's resource person. A warm welcome to Dr. D. Ramaseshu sir, who is the professor of Civil Engineering Department of NIT Warangal, who was born on 15th August of 1964 in Khammam. He has his high school education in Khammam and has obtained bachelor degree of civil engineering from OU College of Engineering, Hyderabad in 1985. And he has done his MTech or ME Structural Engineering from Indian Institute of Science, Bangalore in 1987, and PhD from Regional Engineering College, Warangal. And now he is presently working in NIT Warangal from since 1995. And if we discuss about his alma mater, he has joined in REC, which is Regional Engineering College at that time, which is now known as NIT Warangal in 1990. After working for 3 years in Kids College in Warangal, he has more than 35 years of teaching experience and research experience. He taught several courses at BTech and MTech level with a good practice of sharing latest practical information. He has 6 patents, out of which 3 granted and 3 filed in the field of concrete materials and structures. He has guided more than 90 PG dissertation works and supervised 6 PhDs in the field of structural engineering. He has more than 130 research publications to his credit in international and national journals and conferences of repute related to concrete materials and structures. He has carried out several consultancies, which include design of scaffolding bridges, punch entry and underground mine support systems for SECL, blast fence for Hyderabad Airport, design of prefabrication and at Veligonda Tunnel project, structural soundness of estate and factory buildings of Ordnance Factory Medak, and load testing and non-destructive testing evaluation of bridges, pre-engineered building structures, repair and rehabilitation of concrete structures, etc. in the field of industrial experience if we discuss about. And he has received Outstanding Concrete Engineer Award for the year 2023, that is latest year, from the Indian Concrete Institute from Ultratech Warangal, Telangana State. He is an alternate member of Bureau Indian Standards, and he has concrete subcommittee representing NIT Warangal, member of IRC B5, Steel and Composite Committee, fellow member of Institution of Engineers India, and member of Indian Concrete Institute ICI and Indian Society for Technical Education ISTD. He is a receiver of International J of Structural Engineering and Mechanics from Korea, and ASCE Materials and Adjudicator of PhD thesis, member of BOS and Research Advisory Board of several universities. He has visited Singapore and Indonesia for presenting research papers in international conferences. He has been delivering keynote and extension lectures at several organizations, which include ESCI, VMC, and INCAD, APGenco, OU, JNTU, AU, SVU, and other universities. Apart from teaching and research, he has also carried out diligently the other responsibilities in NIT Warangal, such as Head Department of Civil Engineering NIT Warangal, Head Structural Division, in charge Structural Engineering Laboratories, faculty in charge for construction of G+9 floor story building, halls of residence at Ultra Mega Hostel of NIT Warangal, construction of Center for Innovation and Incubation, professor in charge of Project Engineering Unit, warden of REC hostels, treasurer, Teachers Welfare Association of NIT Warangal. He is currently the Dean International Relations and Alumni Affairs at NIT Warangal. So, with a due respect, I request Dr. D. Ramasesha sir to take over the session and start the session. Thank you, sir.
Sir, please unmute yourself, sir.
Yeah, good evening to everybody.
Yeah, good evening, sir. Go ahead, sir.
Yeah, right. So first of all, let me thank the authorities of this Ramchandra Engineering College here for giving me an opportunity to interact with you all. Okay. So I'm going to present this today's lecture. Are you able to see the presentation?
No, sir.
Hello?
No, sir. Not visible, sir.
And now?
Yes, sir.
Yes, sir.
Okay, right. Just wait. This there is a small problem here. Okay, are you able to see now? Hello?
Yes, sir.
Yes,
Yeah,
sir.
right. That's right. Okay. Sorry for the initial delay. Yeah, in the today's presentation, I'm going to talk about the earthquake resistant design and some concepts which are given in the IS 1893, the code of practice for the earthquake resistant design, with a special reference to the aspect of ductility. This is what the today's presentation title. Now, recently the there is an echo coming. Are you able to listen?
Yeah, your voice is clear and everything is fine, sir. Go ahead, sir.
Right. Okay. Because I am getting the echo actually. Okay, right. So in the recent times, both the Telugu states have experienced the earthquake. Of course, it is a small intensity, small magnitude earthquake. However, it has created awareness among the people of these both the states. So in this context, this particular topic assumes some significance, and we'll try to know certain aspects related to the earthquakes and earthquakes resistant design. So in this lecture, I am going to talk about the earthquakes, causes and effects, and some of the concepts of design, and what are the different measures to reduce the seismic demand. And also, IS 1893 holds clauses.
Excuse me, sir.
Yeah, please.
If it is possible, please put it in slideshow mode, sir. So because many people may attend through mobiles, it may look smaller.
It is in the slide show mode only.
Okay. Then it's okay, sir. Go ahead, sir.
It is in the slide show.
Yeah, go ahead,
Okay.
sir. Go ahead.
Right. So IS 1893 own causes and changes. Okay. Now let us see what are the earthquakes. Earthquakes are the nature's greatest hazard and also least understood, totally unexpected, instantaneous. They cause instantaneous devastation. So because of this, they are unique. They present a unique situation. That means in that sense, they create a unique psychological impact. So why these earthquakes are unique, first of all? First thing is, suppose if you are standing in an open area, you don't feel an earthquake. You may feel some earthquake, but no damage will be there. But if you are in the mid of the buildings, etc., the man-made construction, definitely there is going to be havoc in that particular region because of the earthquake. So that is why the hazard to the life is almost associated entirely with the man-made structures. Okay, so even a successful prediction cannot eliminate the earthquake hazard. Suppose if you are able to predict the earthquake occurrence, even then it will not be able to eliminate the hazard actually. Because even if all the people are evacuated safely, the structures which largely determine the standard of living get destroyed, leading to the great loss to the national or regional economy. So that is why they are unique. Now, if you just look at small methodological aspects, there are 5 natural disasters in general. So they cause devastating effects. They are the forces of the nature. For example, Prithvi, if you see, they cause we'll see the earthquakes and landslides associated with this Prithvi. Then the tsunami and floods are associated with gel. Similarly, Agni, fire and volcanic eruptions. Vayu creates cyclones and hurricanes. Akash, the lightning affects it. So all these disasters will have a profound environmental effect and a human loss, and frequently incurs the financial loss. So what are the earthquakes? Just a few things about earthquakes before we go into the certain concepts of the design. So why earthquakes occur? There are different theories. So one is, out of that, there are 2 popular theories are there. One is the elastic rebound theory. Another is the plate tectonic theory. So in the elastic rebound theory, that is the shaking or trembling caused by the sudden release of the energy. So here what will happen is there is large rock masses will be there. The rock masses which they are experiencing the forces because of the overburden pressure, whatever it may be. So because of that, the rock masses will try to bend. So you know that rock masses are very brittle in nature. So they may not be able to sustain this particular bending. So when they approach the limit, there is going to be a...
Sir, sorry for interrupting.
Yeah, please.
Sir, can you make the screen visible fully? Because...
It is full only.
Okay, sir, okay. Sir, down there some options are there if you try those.
One minute.
Sir, if possible, okay, otherwise. Sir, go for slideshow at the tops.
That's what
Once.
slide. It is there in the slideshow mode only.
Okay, sir. Okay, okay. Okay, sir. Continue. Thank you.
The
Now it is.
percentage is reduced.
Now it is okay, sir.
Okay.
Thank you, sir. Thank you. Thank you.
Right. Okay. Now, as per the elastic rebound theory, these rock masses, when they break, they release the large amount of the energy. That energy is converted as it shows up as an earthquake actually. So this is what the elastic rebound theory says. So this may happen either due to the faults or the different types of the natural elements in the earth. There is another theory which is a plate tectonic theory. Entire earth is composed of different plates actually. It's not a continuous mass. The earth's crust is not a continuous mass actually. So it is consisting of different plates. All these plates will be moving each and other, and they try to collide with each other. So, for example, particularly our India is a part of the Australian plate, actually Indo-Australian plate, which tries to collide with the Eurasian plates, actually. So that is why that particular boundary where the Himalayas exist, there continuously the plates will come and collide with each other. There is a possibility of large number of earthquakes in that particular region. So these are the different theories: elastic rebound theory and plate tectonic theory. That's also called as the continental drift. So because of the movements of these plates, somewhere the beneath zone means one plate will go down the other plate, and the another is ridge formation may take place. There is a rise of the earth mass will take place. So like this, there are different theories which explain the occurrence of the earthquakes actually. So if you look at the plate tectonic theory, you will find 80% of all earthquakes occur in the circum-Pacific belt actually. Circum-Pacific belt means that is the Pacific Ocean actually, which adjoins the western coast of the America and the Japan and the New Zealand actually. This is the Pacific region actually. So this region experiences maximum number of earthquakes, okay. That is why this is called as a ring of fire. So if you look at the magnitude of the earthquakes, for example, magnitude means it can range from 1 to 8 or more than that. So very minor earthquakes of intensity up to 3, they occur large in number. Even per day, we can experience 8,000 number of earthquakes that occur, very minor intensity. We may not be even able to recognize that there is an earthquake actually. So, for example, from very minor to, if you move upwards, minor, light, and moderate earthquakes. For example, the one which has occurred recently, which is can be considered as a moderate earthquake of magnitude between 5 and 5.9. Such earthquakes will occur annually. They may occur in the number of 800 to 900. Such earthquakes will occur. Okay. Now let us see some terminology which is with respect to these earthquakes. The terminologies are, the one is a focus point, another is epicenter point. So what is this focus point? Is the point within the earth where the faulting begins, where the disturbance actually occurs, that is called the focus point or hypocenter. And the point directly above this focus on the surface is the epicenter. These are the general terminology which we are all aware of that. Now let us see, whenever there is a disturbance in the earthquake at the focus point, the seismic waves gets generated, and these seismic waves travel long distances. There are 4 types of seismic waves. The one is a primary wave, another is a secondary wave, the third one is a low wave, and the fourth one is a Rayleigh wave. The P waves, almost the primary waves, they travel with the velocity of sound, almost 330 meters per second. They travel with that speed in air, whereas 1450 meters per second in water and about 5000 meters in rocks, that is granite, etc. These are the P waves are like a push and pull waves actually. The P waves are push and pull waves. Whereas secondary waves, they have a nearly half the speed of the primary wave. That is, if it is 300 meters per second, then this will be around 150 meters per second. So see, these secondary waves, they cause the movements side to side movement, whereas the primary waves push and pull type of movement will be there, whereas secondary waves, they cause the side to side movement. Now coming to the low waves, they travel in a sideways in horizontal plane. They cause lot of disturbance. Similarly, Rayleigh waves, they are elliptic or vertical. That means some kind of a circular movements will take place. Of all these primary, secondary, low and Rayleigh waves, the low and Rayleigh waves, they cause lot of disturbance. Okay, compared to the primary and secondary waves. Primary waves, they cause a little disturbance, but secondary waves, they cause a little higher disturbance. Now coming to the recording of this seismic activity. Normally we hear the seismographs. They record the earthquake event. That's a very simple instrument. Their basically principle is very simple actually. Any seismograph, any seismic instrument, they consisting of a support like this, and there is a pendulum which is hanging from this particular support. The pendulum is a flexible element, whereas the support is attached to the ground. Whenever there is a ground movement, the support column, it moves along with the ground. Because of the inertial effect, the pendulum tries to stay in its own place because of the inertia. So then there is a recorder will be attached to this particular pendulum, and that records the seismic event in the form of waves, etc. So that's why we get a typical seismogram like this. In any seismogram consisting of the primary waves and followed by secondary waves and followed by the other kinds of waves. So here you can see different types of typically recorded the seismographs actually. We call that as the accelerographs. Okay. Now coming to the how earthquake's epicenter is located, first of all. Suppose if there is an earthquake, how the people are able to locate the where is the epicenter of this particular earthquakes. So for this, from the seismic record, what is the seismic record gives is the time of arrival. Suppose at certain time the primary because primary waves travel very fast, they reach the particular point other than the other waves. Okay, so primary waves is the first one to reach to a particular point, so that causes a small disturbance. So that is, let us say, time t1. Okay, then after some times later, the secondary waves will arrive at that particular same point because they travel at a lesser speed. And let us say that is the time of occurrence of the secondary waves at that particular point is t2. So there is a difference between these two times. That is a difference in the arrival of this primary and secondary waves, t2 minus t1. So if you know the t2 minus t1, the gap in terms of seconds, then you can find out where is the distance of this focus point or epicenter point actually. For example, in the graph that you can see here, whenever the time gap between the primary and secondary is large, the epicenter is located at a larger distance. Epicenter is located at a larger distance. This is the way the people can identify at what point at what location or at what distance the particular earthquake has occurred. Now the question is, we know the distance at which it has occurred, but if I ask a question, it's not the distance, it is the specific point where it has occurred actually. Suppose if I say 200 kilometers from this particular point earthquake has generated with 200 kilometers either to north or south, or east or south, I mean west, something like this. How to locate that particular specific point? Actually, for locating that epicenter, actually recording of 3 different stations are required. 3 different seismograph graphs indications are required actually. Why the 3 seismic recordings are required is, suppose if you look at this particular figure, suppose first station, there is a stations like B, D, C, something like this. Suppose a particular station will indicate that the earthquake has occurred at a distance of 200 kilometers. The another station which indicates that earthquake has occurred at a distance of 500 kilometers. So if you draw a circle with a 500 kilometers radius or whatever it may be, so these 2 circles will meet at 2 different points actually. So we do not know which point the intersection point is the origination of the earthquake. That is why third station is required to locate exactly the particular location of the earthquake. The third seismic station, suppose for example, it says 800 kilometers, the earthquake event has occurred. So if you draw with 800 kilometers radius, the third cycle will go through the intersection of all these 3 circles will be the point at which the earthquake has occurred. This is the way, of course, nowadays all this has been done automatically, but this is a procedure they adopt to locate the epicenter, exact location of this epicenter, etc. Now let us see how they identify the magnitude of earthquake. How they identify, there are certain nomograms are available, standard charts are available. For example, if you know the distance at which the earthquake has occurred, for example, let us say 100 kilometers, the distance. Okay, then if you know the amplitude that is recorded by the seismic instrument, amplitude of the wave actually, some 10 millimeters, 20 millimeters, something like that. So if you join this distance point with the amplitude point, then this particular line will intersect the magnitude line. So wherever it intersects, that is the magnitude of that particular earthquake. Suppose for the same 100 kilometers distance, if the amplitude is more, then the intensity of the magnitude of the earthquake is more. So like this, they will be able to locate the earthquake as well as find what is the magnitude of the earthquake actually. Now coming to there are 2 ways of measurement.
Somsekhar sir,
Yes, sir.
I think it's presentation was stopped.
Sarhas.
Left due to technical issue, maybe.
Maybe technical issue, sir.
Let us see.
I request all the participants to prepare for a few minutes.
Sir, if he didn't turn up within 5 minutes, ask Sombabu sir to call him, sir. Maybe he thinks that everything is fine, but we are unable to reach him.
Sure, sir. Sure, sir.
There is a small problem.
Yeah, you are already back.
There is a small power disturbance is there.
Okay, sir. No issue, sir. Go ahead, sir.
Okay, are you able to see this?
Yes,
Yes,
sir.
sir. Yes, sir. Continue, sir.
Right. Okay, there is a power disturbance was there. Okay, right. Now let us see. Yeah, there is two ways of measuring this earthquake. One is the intensity point and another is the magnitude point. Difference between these things, intensity is a qualitative measurement of an earthquake, but exact measurement comes from the magnitude only, quantitative measurement. Qualitative means the amount of disturbance it causes. That determines the intensity of the earthquake. Whereas the magnitude is same, for an earthquake event, generally magnitude is same at all points, whereas the intensity differs. Intensity depends upon the devastation or the disturbance that it causes actually. Now let us see, if you look at this particular table, earthquake magnitude versus the energy that gets released. You can also see approximate energy equivalence also. For example, if you look at the magnitude 6 earthquake, the energy released will be an equivalent to 1946 atomic bomb. Whatever the atomic bomb that has released energy, that much of energy gets released if the magnitude of earthquake is 6. So like that, for every increase, for every one increase in the magnitude, for example, 4 to 5 or 5 to 6 or 6 to 7, the energy increases, the increase will be around 32 times of energy gets released. Suppose, for example, if an X amount of energy gets released, if the magnitude is 4, whereas if the magnitude is 5, 32 times X, that is the energy that gets released. So like that, every time 32 times it increases. So that is the part of the energy release aspect, etc. Now coming to the Indian Indian continent, we have got a IS 1893 code of practice is there. So initially in IS 1893-1984 code of practice, as per that, the entire India was divided into 5 zones: zone 1, 2, 3, 4, and 5. Zone 1 is almost the Deccan Plateau range, which is almost considered as a safe from the point of view of earthquakes. But between 1984 and 2002, there is a lot of earthquakes even occurred in this particular zone 1. So that is why they felt that zone 1 is also not safe from the point of view of earthquakes. That is why they merged the zone 1 with the zone 2. So now, as per the current code of practice, we have got 4 zones. Zone 1 is not there, but 2, 3, 4, and 5 are there. So you can see the zone 2, almost the 2 Telugu states, most of the part of the Telugu states come under zone 2, but particularly the Godavari zone, they come under zone 3. Godavari and Krishna Delta regions, they come under zone 3 actually. So this is what the zoning of the Indian continent. So now there is a revision which is in the annual. Soon we are going to get the new code, the new revised code for IS 1893. There they have introduced another zone, zone 6, which is a more severe zone from the point of view of earthquake. So in the coming codes, we'll have again 5 zones will be there. That is 2, 3, 4, 5, and 6. So 6 is going to be added. Okay, that whenever it comes, we'll discuss that. So at present, there are only 4 zones, 2, 3, 4, 5. So now let us see what is this concept of this earthquake forces, etc.? Any building will have a mass as well as stiffness. Mass as well as stiffness. For example, here you can see there is a time period which is related to this both mass and stiffness by 2 pi under root of m by k. Suppose if the particular building has a lower stiffness means the flexible one. The smaller k value will normally, tall buildings will have a smaller stiffness values. So smaller stiffness means the time period will be very large. So tall structures will have a longer period structure. Tall structures are a longer period structures. Whereas the shorter structures, they have a more stiffness. If the mass may be more, then the smaller structures will have a smaller time period. So this is the way we can understand in general the time period of the buildings. Time period of the building. This time period is very, very important, because the time period is the one which decides the actually the magnitude of the intensity of the earthquake forces. Because we are going to use a particular graph which is given in the IS 1893. That is, the graph is between spectral acceleration versus the time period. So the time period, you can see this particular graph. The time period is, let us say, 0.5 seconds for a particular building. It experiences maximum spectral acceleration. Almost SA by G is 2.5. What is this SA by G? The acceleration is 2.5 times the acceleration due to gravity, 2.5 G. Suppose any other building which has got a time period of, let us say, 2, instead of 0.5 seconds, if it is 2 seconds, its spectral acceleration is going to be, SA by G is going to be 0.5 only. So that is why it experiences less intensity of the forces, etc. Of course, it also depends upon the type of the soil on which the building is resting. Okay. Now let us see some of the effects of these earthquakes. Some of the failures during the earthquakes. There can be different types of failure. For example, soft story fail. Soft story means a particular story has a stiffness, lesser stiffness compared to the other floors. So the soft story buildings, within that particular floor where the stiffness is less, that particular floor is going to experience the maximum earthquake forces, and that is going to fail. So these are all these certain images which will indicate you how the failures will take place because of the soft story and weak story. Weak story is related to the lateral strength, whereas a soft story means it is related to the stiffness of the system, building system. Weak means it is the strength, lateral strength of that particular floor. Okay, we will come to this aspect. Similarly, some more failures, that is, building can move off the foundation, which is causing the failure, and columns may fail, and bending of these columns will take place. Bending of these columns will take place. Similarly, because of the high center of the mass, there is a possibility of resonance may occur. Resonance occurs means there is a lot of damage that is going to occur. Resonance means the time period of the building matching with the period of the earthquake waves actually. So whenever there is a matching of these things, there is going to be a lot of amplitudes will take place. Because of this, lot of disturbance will take place. And during the earthquake, there can be a falling objects, and coming to the ground failures, there can be liquefaction. Liquefaction means almost the soil, the foundation soil behaves as if it is a liquid. So that doesn't have any shear carrying capacity, and the building will sink. Okay. So that is the liquefaction effects. Overturning effects, and there can be opening of these faults will occur, and damages to the canal structures, etc. Anything, and there can be different types of failures. We can see bridge failures, pipelines crossing the fault, they get damaged, etc. Similarly, the damage to the tanks, RC staging, steel staging, or whatever. RC cantilever slab, particularly cantilever slabs, they are the first elements to fail in earthquake forces, because in an earthquake event, if the amplitude of a normal frame is, let us say, some x, but whereas the cantilevers will experience 3 to 4 times that particular amplitude. So that is why they are the one which are going to fail faster. And there can be pancake type failure. That means one slab falling into the other slabs, etc. The other downward slabs. And yeah, this particular figure, you can see how a column gets damaged. Here you can see in the first picture, they all lateral ties. Where lateral ties, you are not able to see any lateral ties actually. All these lateral ties got opened up. So there is no tying of the main bars. There is no tying of the main bars because of the opening of the ties. So that is normally we call that as a confinement failure. Confinement failure. That is, there is no confinement to the core concrete. So that causes a failure particularly. So we'll discuss about this confinement later. And particularly unreinforced buildings, unreinforced masonry structure, they suffer a lot. For example, infield walls or even the brick masonry walls, they are subjected to crisscross cracking actually. Crisscross means into type of cracking will occur because of the cyclic movements of the ground or shaking. Okay, so those are all some of the photographs which indicate how the failures will take place, etc. Now coming to the what are the concepts of design? Here the concept of design is very simple. The capacity shall be greater than demand. That is a concept of design. Capacity means the building capacity, whether it is a stiffness point of view or the strength point of view, which has to be greater than the demand. Demand means whatever the earthquake forces that comes. So if the capacity of the building is more than the earthquake forces, induced forces, then the building gets survived. So that is what the concept is. Then how to achieve this particular thing? Here you can see the different figures. One is a capacity curve. Capacity curve means which represents the structure's ability to resist the seismic demand. So that goes like this. Okay. Similarly, demand spectrum. Demand spectrum means that is SA by G versus time period or spectral displacement or spectral acceleration spectrum, etc. So that is a demand spectrum, we call this. If you superimpose these two, that is capacity spectrum and demand spectrum, these two gets intersect at certain point. That particular point we call it as a performance point. So performance point, as far as possible, it has to be near to the linear behavior, linear portion of the capacity curve, or slightly non-linear portion of the capacity curve. So if it moves further, what happens? There is going to be failure of the things. So now, how to achieve these things? So it's a good practice to reduce the seismic demand to the extent possible. To the extent possible, it is necessary to reduce the seismic demand. How we can do that? So this can be done at the conceptual stage by selecting a suitable structural system. Suitable structural system. So now I am going to discuss about certain measures that you can take which will reduce the demand, seismic demand, so that the structures get protected. Here I have listed a few of the measures which are going to reduce the seismic demands. Starting from selecting of the suitable site with favorable soil conditions, or avoid using unnecessary mass, etc. So we'll discuss one by one. First one is selecting suitable site with favorable conditions. For example, if the site selected consisting of a soft soil, that means the bearing capacity is very less, soft soil. The problem is whenever the seismic waves travel through the soft soil, they get amplified. Amplified means the magnitude of the displacement gets amplified actually. So that causes a lot of disturbance to the structures which are existing in that particular region. And there is a possibility of liquefaction can take place. Liquefaction, you know that wherever there is a vibration or the sudden movement of the soil grains, they lose the one-to-one attachment and they behave as if they are liquid only, losing all the shear strength. So that causes the severe settlement of the building, etc. So selecting a suitable site plays very important from the point of earthquakes, and they can cause the overturning or failure of the mat foundations. These are all the reasons for the weak site or the site which are having a less capacity, less bearing capacity, etc. Soft soils, for example. Then another aspect is apart from the selecting the suitable site, the another point that you can take care is avoid using unnecessary mass. Avoid using unnecessary mass. For example, you can see you should not have a plan of the building or the such that there is a heavy eccentric mass in the top floors located, whereas a light weight is located in the down the floors. So that causes unnecessary mass placed at a very top. So that causes a lot of forces which are likely to act on the building and cause the failure of it. Here you can see there is a building wherein in one of the floors, in the first floor, they have got a heavy mass, and the heavy roof garden was there actually. So in the event of earthquakes, the floor got damaged. So like that, you should not keep a heavy mass, the unnecessary mass. Then apart from this selecting suitable soil and avoiding using unnecessary mass, there is a third point, that is use simple structural layout with minimum torsional effect. Simple structural layout means it should be a rectangular, square, or something like that. Okay, wherever the L-shaped buildings are there, you should give a joint between these two so that they act independently, independent rectangles. So that is a simple structural layout. Why simple structural layout is wherever there is an irregularity either in the plan or in the elevation, it unnecessarily causes the torsion of the building. Torsion means instead of simply moving in lateral direction, the building will turn like this. So that causes torsional irregularity. So that should not happen actually. Then another thing is avoid strength and stiffness taper along the height. What is the meaning of avoiding strength and stiffness taper along the height? That means there should not be much difference between the strength of one floor between the adjacent floors. Suppose one floor has got lateral strength of some, let us say some X. The other immediate floor should have the same strength actually. It should not have a strength much less than this particular strength, etc. Similarly, with respect to stiffness also. So, for example, here you can see some buildings wherein the strength and stiffness taper along the height. For example, in the first building, he has used the floating column. Floating columns means a column which is not originated from the foundation. The column which originates at some of the floors, from any of the floors. It doesn't have a foundation. It takes the beam as a foundation. So such floating columns will reduce the stiffness of the buildings. Okay, so that will have an enormous effect. The second picture you can see, he has left one of the floor without brick walls. So that means that particular floor where there are no brick walls will act like a soft story compared to the other floors. That means which has got a less stiffness. So such things should not be there as far as possible. If it is a compulsory, we have to take measures in the design itself. Similarly, whenever there is a strength and stiffness taper along the height of the buildings, there can be a pounding effects can occur. Pounding effects means one building moves laterally, hitting the other building. So that is why the code says there should be a minimum gap between the two structures. What is the minimum gap that we shall see between the two structures? So that's called pounding effect. Because of this pounding effect, you can see one building staircase is coming and hitting the columns of the other building. So that is damaging the other building. So that is why code says that the minimum gap between the structures is R times the sum of the story displacement. R means that is response reduction factor, R. R times the sum of the story displacement. That should be the minimum gap you have to maintain between the buildings in order to avoid the pounding effects. Similarly, short columns. For example, you can see here the staircase, because of the landing slab, this column height reduces. So if the column height reduces, what will happen? Of course, that has to be designed properly. The column height reduces means short column will have a higher stiffness actually. Then higher stiffness columns, they attract more seismic forces. So they have to be designed accordingly. They have to be designed accordingly. So that is why any rigid element will attract the more forces. That is a general principle. Any rigid element or stiffer elements will attract more forces from the earthquakes. Now coming to the, of course, the same thing, avoiding the soft stories. You have to avoid the soft stories. The soft stories, they cause lateral deformation, and there is a possibility of the formation of hinges that can occur in the soft stories, which causes a lot of damage to the columns, etc. Here you can see that particular building, wherein the series of columns got damaged there. So this is another failure, soft story failure. So that's why, as far as possible, to the possible extent, we have to avoid the soft stories, or if the soft story becomes essential because of the parking purposes, so we need to keep ground floors without constructing any brick wall. In such case, at least you have to take care of by providing bracings, etc., or shear walls, etc. We shall see in the presentation later. Then provide sufficient lateral bracing and drift control by using structural walls. For example, here you can see two buildings. In one of the buildings, there is no drift control. Without drift control, there are no shear walls or bracings, etc. So that has caused a lot of damage here. The other buildings, in the form of shear walls, there is a lot of drift control measure has been taken place in this particular building. So provide sufficient lateral bracing and drift control. Similarly, isolate the non-structural elements. Whenever there is non-structural elements are there, because they are going to be gets damaged. Whenever there is a lateral movement, non-structural walls, infill walls, etc., they get damaged heavily. That's why you have to have a separation between these non-structural and structural elements in order to avoid the damages. Okay, these are all the certain measures. So far, we have discussed certain measures that has to be taken to avoid the seismic demand, to reduce the seismic demand actually. Okay. Now coming to the seismic design requirement. Nowadays, we are following the capacity design method. What is this capacity design? In this capacity design, certain selected elements of a structure, either it can be a beam or a column, etc., critical places, critical elements, they are designed in such a way that they remain elastic. Whereas the other parts of the other elements, other part of the beams, etc., they go into the plastic regions. Okay. So that is why this is what the general principle of the capacity design. But this capacity design heavily relies on the concept of moment redistribution and ductility concept. Moment redistribution and ductility concept. Now let us see what is this moment redistribution. So this is a very important concept in the design of structures, moment redistribution. So what happens in the normally if you analyze a frame, let us say, if you analyze a beam, let us say, for example, beam under linear response conditions, it shows up some bending moment diagram. It shows up some bending moment diagram. But what happens if you go on increasing the load? If you go on increasing the load to ultimate, so what will happen? These beam will act. I mean, there is a possibility of the hinges will take place. Plastic hinges will take place. Why plastic hinges will take place is because of the non-linear stress strain behavior of the constituent materials. Because of this, the plastic hinges may take place at certain location, not all locations. Now, what is the effect of this plastic hinges is the formation of plastic hinges will convert or will transform a indeterminate structure towards the determinate. For example, a fixed beam is there. If a fixed beam is subjected to, let us say, UDL, if you keep on increasing the UDL, the supports, the fixed supports will experience the heavy bending moment. Whenever this particular bending moment reaches the capacity of that particular section, we call that as a plastic moment, MP. Then above that, after that, there is no increase in the moment at that particular point. Then what will happen when you increase the load? When you increase the load, the moment has to go somewhere. And wherever they reach the plastic moment capacity, there is no increase in the moment. So increase in moment should take place at other sections where lesser bending moments are there. So that is causing the plastic hinges to form at other locations. So ultimately what will happen is any indeterminate structure will transform to a determinate structure with the formation of plastic hinges. Once it has transformed to determinate structure, whenever there is a formation of one more hinge, is sufficient to cause the failure of that particular structure. This is the concept of moment redistribution concept. Here in this picture, you can experience that. For example, here there is a beam subjected to concentrated load. So if you increase the concentrated load, there is a definitely bending moment at the mid span is higher. So there is a formation of plastic hinge. So if it is simply supported beam, already simply supported means the supports, they are already hinges actually. Hinges means the bending moment at the supports is zero in simply supported beam. So whenever there is a formation of another hinge in the mid part, then that becomes an unstable structure. It's no more a stable structure actually. So that leads to the failure of this. Why? In this process, what will happen is and the cross section, entire cross section becomes plastic actually. Entire cross section becomes plastic. Then only that converts into the hinge, plastic hinge. We call it as plastic hinge. Here you have to understand one difference between the plastic hinge and normal hinge. Plastic hinge, in a normal hinge, the bending moment is zero. But at the plastic hinge, the bending moment is not zero. Bending moment is equal to MP. MP means maximum plastic moment capacity. That is the difference between normal hinge and a plastic hinge. Okay. So this is of course, this figure explains the formation of the plastic hinges actually, and the resultant change in the bending moment pattern. For example, if you look at this particular figure wherein the fixed beam is there subjected to UDL, under elastic conditions, the first one is the bending moment diagram. But whenever the formation of the hinges takes place, the bending moment diagram becomes something like this. So you can observe the 2 points. Here the point of contraflexure in the linear bending moment diagram is at this point, whereas point of contraflexure has been changed to some other location in the ultimate bending moment diagram. Then what will happen to the bending moment between these two locations? Between these two locations, entire bending moment got redistributed. That means where the bending moment is, some bending moment is there, now that bending moment has become zero at that particular point. So that means there is a 100% redistribution of the bending moment has taken place at certain region. So this is called the redistribution of the moments. Of course, as far as the redistribution of the moments is concerned, the IS code has got certain limitations. IS code has put certain limitations. For example, if you see the clause number 37.1.1, the neutral axis depth ratio x by d should be less than 0.6 minus delta m by 100. What is delta m? Delta m is the percentage of the redistribution. Percentage of the redistribution actually. So percentage of redistribution, let us say if it is 30% redistribution is there, for example 0.6 minus 30 by 100, that is 0.3. That means x by d shall be less than 0.3. X by d shall be less than 0.3 for 30% redistribution. Similarly, for 50% redistribution, you will have a still lesser value of the x by d will be there. Whenever if you allow the more redistribution, the problem is it demands more rotation capacity, more rotation. That's why we know that the concrete is not so ductile compared to the steel. So we cannot allow the 100% redistribution in the concrete. That's why the code restricts maximum of 30% only redistribution. Okay, because they know that this is not possible in concrete. Now coming to the limitations of the moment redistribution is particularly with respect to RC sections. You know that RC sections have got a limited rotation capacity. Then how to increase this rotation capacity in order to have a more redistribution of the moments? So rotation capacity depends upon ductility of RC sections. What is ductility now? So let us see a few aspects of this ductility. Before that, I have a small question here. Suppose if I ask you whether you want an earthquake resistant building or earthquake proof building. Earthquake resistant building or earthquake. Okay. So what is the difference? Okay. Earthquake proof means no damage. But this concept is incorrect. Okay. Why? Because the estimation of the forces we cannot estimate correctly. Because of the earthquake, nobody can predict how much is what is the earthquake force that is likely to happen because of the uncertainty. Okay, of course we have got some methods are there to estimate the forces. How far these methods are reliable? So that is why estimation of the forces there is an uncertainty. Then unpredictability of earthquakes. Then unstable ground conditions, unexpected faulting of the ground, etc. So all this will give an uncertain situation. So that is why earthquake proof building, that is a building with no damage is not possible. It's not correct also. We have to accept some damage. That means in the event of earthquake, there is going to be some damage that needs to be corrected later. So that is why the code suggests only earthquake resistant building, not earthquake proof building. Okay. Now coming to the IS 1893-2016 code, there is a zoning map is given. Of course, this zoning map we have discussed earlier also. This is consisting of 4 zones. Country has been divided into 4 zones. And with the increasing order of the seismic vulnerability or seismic demands actually. Now coming to this, what this IS 1893-2016 code says, even 2002 also compared to the 1984. The concept is very simple here. The concept is like this. Resistance of large seismic force to the evasion of the force. That is the concept. Let us try to understand what is this resistance and what is this evasion of these forces. So now here you can see a small picture wherein two trees are shown here. One tree is like a banyan tree, very huge trunk, huge stem, etc. The other tree is a very slender one, like a palm tree or like grass or whatever it may be, which is very flexible actually. Now let us see how these two types of structures. One is a rigid structure, another is a flexible structure. Okay, how these two types of trees will face the extreme events either due to wind or due to earthquake or whatever it may be. In case of lateral forces, either wind or earthquake, both they induce the lateral forces only. So in this case, you can see the huge tree thinks that it is very strong. I can resist any amount of the wind or any amount of the earthquake lateral forces, but ultimately it gets uprooted. But whereas the palm tree, which is a very clever tree, very flexible tree actually, so it is very much aware that it cannot resist the forces. So that is why it will bend. It will show a bending pattern. So because of that, the ego of the forces gets satisfied. Just I'm telling jovially, ego of the forces gets satisfied. So whenever this the earthquake forces or the wind forces they pass off, then again this particular tree comes back to its original position. That is why even in the in our life also, whenever we face the extreme situations, there is nothing wrong to have a one step backward. Okay, so that when the situation gets corrected, then we can move forward actually. So that is the concept, the IS 1893 or most of the codes, seismic codes they prescribe. That is why instead of instead of resisting the force, let us try to evade the forces. Evade means just pass on the forces. Okay, that is the concept. Then how to do this? This saying is very simple. Instead of resisting, you evade the situation. That is saying is very simple. But how to bring in that concept into the structures actually? Okay, so that concept we can introduce by encouraging the structural forms possessing ductility. Not only strength, but ductility. So if the structure has a ductility, definitely under gravity loads, a structure behaves as if it is rigid. But under the extreme forces, the structure will behave as if it is a flexible one. So that is why this is possible only when the structure has sufficient ductility. What is this ductility, or let us say two? So before that, there are two distinct designs of the buildings that result in different earthquake performances. Two distinct designs. One is in one design we go for strong column, weak beam. In another design, if you go for weak column, strong beam. You just see here, in case of strong column, weak beams, because the beams are weak, most of the plastic hinges forms only in beams, not in columns. Only in the ground there is possibility of columns hinges actually, but all other hinges they form only in beams, not in columns anyway. Whereas in a weak column, strong beams, there is no possibility of the hinges in the beams. The hinges will form only in columns. This is a dangerous situation actually. You can see here, for example, in a strong column, weak beam, because of the formation of the hinges in beams, let us say there is a lateral displacement of delta in the top floor. So what is theta 1? Theta 1, you can see delta divided by the height of the building. Let us say if there are the 5 floors are there, 5 into h, each floor height is h. So delta by h is a theta 1. That is a rotation capacity required for the column. Whereas in the second, that is wherein the weak column and strong beam is there. For the same delta, theta 2, you can see, theta 2 simply becomes delta by h. That means denominator has reduced actually. So because of the reduction in the denominator, in the first case it was total height of the building, whereas in the second case it's only the floor height of the building. Okay, so that is why theta 2 will be much higher than the theta 1. That means rotation capacity required in the second case is much higher than the rotation capacity in the first case. That is why we know that concrete cannot undergo that much of the rotation capacity. So we prefer to go for the first type of design, that is strong column, weak beam concept. Okay, this is the concept of the code that prefers. So because of this, of course, code also prescribes certain performance objectives under different intensities of the ground shaking. So performance objectives are like this. I mean, it can be low repairable damage to the collapse prevention. For example, minor shaking, there can be low repairable damage. Whereas in a strong shaking, there can be heavy damage, but the structure should not collapse. So these are certain performance objectives the code prescribes. So you can see this particular figure. This explains how this performance-based design will go. For example, building performance, there are different building performance levels. One is fully functional, that is the one performance level. Another is operational. Another is life safety. Another is near collapse. These are the performance levels. For example, if there is an ordinary building, whenever there is a frequent earthquake is there, ordinary building has to be operational. That means it should not collapse actually, operational. Okay. For example, if you see the rarest type of earthquakes, very heavy earthquakes, the ordinary building reaches near collapse region. This is the point, near collapse region. The performance for ordinary building transfers from operational performance level to that of near collapse region. Okay. Similarly, if you see the hazardous facilities means the failure of which causes a lot of havoc. For such buildings, we should not force the building till the near collapse. The buildings should be operational even in the event of rarest of rare earthquakes. That is the performance objective with which the buildings are designed. So to achieve these performance objectives, the ductility is very, very essential. Providing ductility in a structure. Now let us see what is ductility. Okay, what actually ductility gives. Ductility assists the structure in providing robustness for the structure. Second point is it gives warning of the incipient collapse. Third point is it enables the statically indeterminate structure, SI structures, statically indeterminate structures to go into the redistribution levels. Then the fourth one is when there is a ductility in a structure, it enables major distortions to be accommodated and most of the energy gets absorbed in the structure. This is the advantage of having ductility in a structure. Robustness, warning, redistribution, and energy absorption. These are the four things the ductility will provide. What do you mean by robustness? So here you can see a picture. Robustness means a collapse of a certain part of the structure. Collapse of let us say a beam, small beam in an entire structure. If there is a collapse of such beam is there, it should not lead to the collapse of the entire structure. Suppose if one of the beams fails, definitely the load should take different path. Load path should have a different alternate path of distributing the loads. So if there are more number of alternate load paths are there, then the structure is said to be more robust actually. For example, in our children days, we used to play a small play like this by arranging matchboxes or pack of cards like this. If you throw one pack of cards, it causes the collapse of the entire system of the pack of cards actually. That means a small disturbance at one place is causing the entire collapse of the entire system. That means such system is not considered as a robust. Okay, so that means what we understand by robustness is it should have a different load paths actually, multiple load paths, redundancy in the structure. Okay, next is a warning. Of course, this is warning can occur in the form of the development of cracks, crushing, etc., etc. So this warning has to be there. Then similarly, redistribution. This is what we have discussed. This allows the structure to develop the mechanism to reach the ultimate moment. Okay, before reaching the mechanism, it should not collapse. Okay, then energy absorption is the one which is without significant loss. That too, without significant loss of resistance, there should be energy absorption. Okay, so ductility by definition, it is the ability of a structure and components to deform beyond elastic limit, okay, without excessive strength or stiffness degradation. By another definition, ability to sustain the large deformation or capacity to absorb the energy by hysteretic behavior. Here, just look at the hysteretic behavior. What do you mean by this hysteretic behavior? These are the hysteretic behavior of particular joint or particular structure. You can see in the below figure, you can see 4 different figures. One is simple straight lines like this. The other 3 figures have got a curves like this. Okay, each cycle, the energy means whatever the area of this load deformation curve, that is considered as energy. That area under this each cycle is getting reduced. In each cycle, getting reduced actually. That means it is losing its capacity. For example, you can see the last figure. The area within this last cycle is very, very small compared to the area in the lower cycles actually. So that will happen with a column with hinge. For example, A type of behavior is perfectly elastic plastic behavior, whereas the next type is bilinear RCC beam, bilinear behavior without formation of the hinge. Similarly, third type is RCC beam with the formation of the hinge. The fourth type is a column with the formation of a hinge that behaves something like this. So that is hysteretic behavior. What do we understand from this particular behavior is it should not, in every different cycles, the member's capacity to absorb the energy should not get reduced. It should maintain the energy absorption capacity. So that is the way that is possible only having ductility, etc. Now, how we measure the ductility? Ductility is measured in different ways actually, either with respect to the deformations, delta U ultimate to the yield deformation is called as a ductility. Similarly, ultimate strain to the yield strain is also considered as a strain ductility. There are different types of ductility. One is the structural ductility. If you are measuring with respect to displacement, it is called structural ductility. If you are measuring with respect to the material or the strains, it is called as a strain ductility or material ductility. Something like with respect to this ductility, there is a concept of chain analogy concept. For example, there is a chain, the different links are there. All these red color links are brittle links, and the one which is shown with hatched one is a ductile link. So it is not necessary. Suppose if you want to make the chain as a ductile chain, it is not necessary to replace all the links with a ductile links. Even if you change one of the links as a ductile link, entire chain will behave as if it is a ductile one. So that is why this is a concept. That means it is not necessary to have a ductile detailing in the entire structure. If you have a ductile detailing only at critical points, then it is sufficient to make the entire structure ductile. So that is why, of course, this is the with respect to curvatures, phi u by phi y. That's also another definition of the. This is for sections. We call this as. Of course, this is the behavior of a particular section which is having a low ductile class, that is DCL, ductility class is low. Similar DCM, the ductility class is medium. DCH means ductility class is high. That is the behavior of the either force deformation curves or moment rotation curves, etc. What are the points that affects the ductility? One is the axial force, level of axial force. When there is a more axial force, there is reduction ductility. Suppose if you increase the compression strength of concrete, increases ductility. If you increase the strength of steel, that is instead of going for 500, 600 steel, if you go, there is a slight reduction in the ductility. Similarly, if you increase the ultimate strain capacity of the concrete, it increases the ductility. So the fourth one is a point for the research actually, how we can increase the ultimate strain capability of concrete so that the ductility can be increased. This is what being researched a lot. Even today, that is being researched a lot, how to increase the strain capability of the concrete. Okay, because that is going to increase the ductility. Yeah, here in this figure, you can see the formation of hinges in case of strong column, strong beam and weak column. Okay. Now, of course, this we have discussed already. So, from the point of view of ductility, the strength and ductility has to be balanced in a particular structure. How to achieve this ductility? Ductility is achieved by having a confinement action. Confinement means suppose if a cylinder is there, whenever you are applying a load, axial load, because of the Poisson's effect, the concrete tries to move in a lateral direction. Whenever you try to press it, the concrete will move in a lateral direction. Suppose if you confine that particular cylinder either by means of a ties or whatever it may be, or FRP, whatever it may be, then the lateral displacements are very less actually. That means that particular cylinder is said to be confined. So this is what the confining action. Confining action increases the ductility. So there are different ways of putting the confinement. Conventional way of putting the confinement is by using the stirrups, ties, hooks, spirals, etc. What is the non-conventional way of achieving the confinement is either by ferrocement confinement or FRP confinement. Of course, fluid pressure confinement is not a practical one, so that also provides confinement. Similarly, confinement can be a discrete level of confinement or continuous confinement. Discrete confinement means, for example, if you provide the stirrups or ties, between the ties, the concrete is not confined. Between the ties or between the stirrups. So that is why it's called as a discrete confinement. Whereas a continuous confinement means if you provide the FRP or ferrocement jacketing type, then that provides a continuous level of confinement. Similarly, the confinement can be passive, can be active also. Of course, active confinement is not practical actually, but passive confinement you can have in the form of by providing stirrups, hoops, etc. Similarly, the confinement can be a low strength, low level of confinement, high level of confinement, high strength confinement. Normally, high strength confinement is possible because of the FRP, use of FRP. So like this, there are different confinement categories are there. Of course, that is being researched actually. Here in this figure, this is of course in 1928, F.E. Richard has come out with the concept of confinement actually. He has applied a fluid confinement and he has shown that the concrete strain capable strains is able to reach a strain capability of 0.06 strain. Whereas today, what is the stress block? What we are using is 0.0035. That is the maximum strain of concrete that we use for concrete. But with proper level of confinement, the strain capacity of the concrete can be 0.06. Compared to 0.0035, 0.06 is very high actually. That is the confinement level that we can have. Okay, these are all the parameters which affect the confinement, which you can find. Of course, this is the confinement of square versus circular sections. Normally, circular sections will have a better confinement than the square sections. Okay. And similarly, effect of spacing of the ties or spacing of the stirrups will have a effect on the confinement. That's natural. Okay. advantages of confinement. It increases the both strength, ductility, improved rotation capacity, etc. Okay, now let us see. I'll try to close it in very short span of time. What are the ductility measures in IS codes? How it can be provided, ductility. In the design, we can have some ductility. We can follow certain clauses to provide the ductility. In the detailing also, there is a detailing clauses are also there to enhance the ductility. So for design purpose, we use the IS 456-2000 code of practice. In detailing, we use IS 13920 code of practice. Okay, as far as IS 456 is concerned, there are certain clauses by unknowingly we are putting a ductility. I mean, for example, restricting the neutral axis depth, percentage redistribution. We will not allow the redistribution. I mean, neutral axis depth to go over and above the maximum depth of neutral axis. That means we are limiting the neutral axis depth in the limit state method. That is, indirectly we are restricting the neutral axis depth, providing the ductility. Similarly, we have got in assumptions, you might have seen the minimum strain at ultimate, that is Fy by 1.15 ES plus 0.002. That is meant for the providing the ductility by having a minimum strain at ultimate condition. Similarly, maximum ultimate strain 0.0035. Then limit on percentage tension steel, percentage of compression steel, maximum limit on steel strength, maximum spacing of the ties, spirals. So all these things are indirect clauses. They indirectly enhance the ductility of the system. Similarly, 13920 also, there are certain clauses are there. That is, stress under axial loading shall not exceed 0.1 FCK. Similarly, B by D ratio, width to the depth ratio should not be more than 0.3. Similarly, B shall not be less than 200 mm, D shall not be more than 1/4 of the clear span. So like this, there are certain clauses which will provide automatically ductility in the system. Similarly, if you look at the provision of the ties or stirrups, the 135-degree bend at the closing of the link, that is very, very essential. Why? Because in case of extreme events, the tie or a stirrup subjected to tension forces. Because of that, the link will open up. So if the link opens up, the confinement is lost. That is why we have to go for 135-degree bend. Similarly, spacing of the ties or stirrups at the overlapping locations. So these are all these clauses which indirectly helps us to provide the ductility in the system. Okay, these things you can find in earthquake tips or in IS 13920 code of practice that you can read for yourself. Okay, I'll just go through these slides. Okay, there are certain popular earthquake resistant techniques. The use of shear walls, that is one of the popular resistant techniques, earthquake resistant techniques. So the function of the shear wall is it maintains the connection for uplift resistance, and also it's a sliding resistance also it builds up. Because of this, there is a stiffness gate control, or stiffness gets increased, which helps in controlling the side sway actually. The shear walls in most of the buildings nowadays, people are going for the shear walls in order to provide earthquake resistance measures. As far as the shear wall is concerned, you have to have a shear walls in a symmetrical positions. Don't have a shear walls in unsymmetrical positions. Unsymmetrical position that gives a poor resistance to the earthquake forces. Okay. Similarly, use of bracings. Already building is constructed. How to make it that earthquake resistance is by providing bracings. That's a better option actually. The different types of bracings are there: diagonal, cross bracings, chevron bracing, that is triangular type of bracing. or eccentric type of bracing section. All these bracings will enhance the or will resist the lateral side sway. Similarly, use of seismic dampers. Use of seismic dampers also you can use to provide the earthquake resistance in a particular building. There are different types of dampers are there: viscous, friction dampers, yielding dampers, viscoelastic damper. You can see all these types of dampers. Similarly, there is a use of tuned mass dampers. Of course, in a very large buildings, particularly they prefer to go for tuned mass damper. Tuned mass damper is nothing but a simple pendulum type of thing. Very heavy mass is which is put, which is in a flexible thing. Okay, so these are all the popular earthquake resistant techniques, applying the reinforcing bands, etc. Use of lightweight materials, base isolators. This is also another technique which reduces the intensity of the vibrations in a particular building. Base isolators. First time in India they have used in the Buj Hospital building after that 2001 earthquake. They have used this is the base isolator. Okay. With this, I'll close this. If you have any small questions, we can ask.
Thank you, sir. Thank you for your excellent and informative session, sir.
Okay.
Now I request Head of the Civil Engineering Department, Dr. K. Sundarkumar sir, to speak a few words regarding the session.
Yeah, there is one small this thing. Just a minute. Yes. Okay. At the starting point, I have shown this particular figure. Okay. What do you understand from this figure? It is self-explanatory. Okay. So I'll just go to the that's right. This is a multiple ways of defense. The first defense is first one is a determinate kind of defense. Number two is a indeterminate type of defense. Number three is a ductile ways of defense. So this is what they explain for that. Okay, thank you.
Thank you, sir. Respected Ramasheshu Garu, Professor of NIT Warangal. Actually, we have, it is a very informative session and very interesting also, and very much connected to this theme of this today's program, that is FDP on disaster risk reduction. Definitely, this ductile nature of design definitely will reduce the risk in the course of earthquakes and all. And very nice explanation, sir. We gained a lot of knowledge through your presentation. Complete all the slides are very much interesting, and definitely we will keep these things in YouTube channel for further usage of the various participants for the later use.
Okay.
Yeah, one or two questions, sir. Yeah. These P waves, S waves, these different waves are there, no, sir. So, where do they occur, sir? Any criteria based on plates or tectonic plates and all, or
No.
do they occur everywhere?
See, any earthquake produces all these types of waves.
Okay.
All these types of waves. Okay.
No predominant waves.
No. In this, each wave will have a different effect.
Okay.
Different effect, and each wave travel with different speed. Different speed. Particularly the primary and secondary waves. Primary waves may not cause a lot of damage, whereas other waves, secondary waves, low and valley waves, they cause a lot of.
Yes, sir. So actually, I am non-structural background, sir. I am environmental and remote sensing background.
Okay.
Let me ask you one silly question. You see a pyramid. A pyramid is a structure which definitely resists any kind of earthquake, in my opinion.
Yeah.
Oh, why not? Why not? The current structures are constructed like at least in the shape of pyramid, not like exactly like pyramid.
See, if you
Means
see pyramid,
yes,
so if you observe the base of the pyramid,
yes, sir.
base of the pyramid is
Yes, sir.
very large compared to the tip of the pyramid.
Yes, sir.
Okay, so that much we cannot afford actually. It's a very huge structure to resist. Okay, nowadays because of the space constraint, etc., we cannot go like a pyramid kind of structure. We have to go the tall and slender type of structures only.
But the damage that is aftermath is
Definitely,
very huge. No? People are
definitely,
losing life.
definitely, this will happen. Any slender structure will have a lot of damage,
Yes, sir.
but that is a requirement.
Yes, sir.
Suppose
Okay.
people have to construct their house only in 200 square yards of area, 100 square yards area.
Okay, sir.
Okay, they cannot have acres of land. Okay,
Okay.
so
Sir, these techniques like shear wall,
yeah,
dampers, and all. So,
that
are
is
they
there.
very costly, sir? Are they very
No,
costly compared to?
shear wall is not a so costly actually. It's
Okay.
not just simple concrete wall actually. But if
Okay.
you want to go for a special kind of like base isolator, etc.,
Yes,
that
sir.
is very costly at present.
Yes, sir. Dampers also.
Yeah, dampers also.
Yeah.
That is why they use only very important structures. They use such kind of things.
So, to improve the ductility, can we use any composite materials, sir? Like in place of steel, can we use composite materials in
Yeah,
the form of reinforcement?
definitely.
Because nowadays a lot of research is going
Yes,
on composite materials
yes, definitely.
with more ductility and high strength.
Yes.
Yes, sir. Okay, sir. Right, sir. Very informative lesson, sir. Thank you very much, sir, to see
Thank you.
you and to listen from you.
Yeah,
And
thank
I
you.
personally gained a lot of knowledge through this session, sir.
Yeah, thank you.
Thank you very much, sir. So, one more minute, sir. All the participants have any questions, please rise quickly because sir is already crossed the time.
Yeah, Naresh.
Yeah.
Good evening, sir.
Good evening. Proceed, ma'am.
Dr. Vaman from Aicte College, sir. Sir, my doubt is when we go for theory, whether what type of foundation is better, whether pile glass or combined footing.
No, there is some echo is coming. I could not understand it. Can you repeat? Anybody can repeat.
Sir, while we are going earthquake resistant structure, the foundation is pile is better or what is better or mat is better?
Yeah, regarding the foundations, in case
Yes,
of soft soils, people prefer the pile foundations. Definitely, pile foundation. In case of hard soils, definitely an independent footings is sufficient actually. Or in case of soft soils, either you have to go for mat type of foundations supported on piles or pile foundations. Definitely, yes.
Yes. Thank you, sir.
Yeah.
Sir.
So with this, we concluding the session.
Okay.
Thank you so very much, sir, for accepting our request and attending this event and attending this session, sir. On behalf of the management of Ramchandra College of Engineering and Department of Civil Engineering, we kindly thank for accepting our request. And the session is very informative. You have covered all the topics from basics to the advanced level of how the earthquake occurs, what is the epicenter, and how we have to take care of all these effects that would occur to the structure if we are going for high-rise buildings. So very thank you, sir, for attending this session and taking this session to the higher level. And all the participants were shown interest throughout the session. So with this, we concluding this session, and we are expecting your collaboration with our college in future programs also, sir.
Definitely.
Thank you, sir. Thank you so very much, sir.
Thank you one and all for your patient listening. Okay.
Yeah. Thank you, sir, and good night, sir. Thank you, sir. Good night, sir.
Right.
Thank you so much, sir.
I'm leaving.
Yeah, you can leave, sir. Thank you, sir. Sir, Somshekhar, sir.
Yes, sir. Yes, sir.
Yeah, please announce the second session details. Who is taking that, sir?
Conclusion, madam will take care of the second session, sir.
Whether she
Madam
is
is
there
online, sir.
online or not. Okay. And also we have to verify whether the Kailash are already there or not.
Am I audible?
Yes, sir.
Yes, sir.
Audible, sir. Clear, sir. Please give 2 seconds, sir. Our coordinator will speak, sir, about the session. Conclusion, ma'am. Please go ahead.
Yes, sir. Yes, sir. Yes, sir. Good evening, everyone. Welcome back to the third day of our FDP on disaster risk reduction through sustainable infrastructure. The session topic is integrated speed management approach to improve road safety. Now, it is my great pleasure to introduce our esteemed speaker, our the session, Mr. Kailash Chandra Tiwari, International Safety Management
Ma'am, your voice is not audible.
Civil Engineering in Traffic and Transportation Engineering from India and Canada. He was born at Mount, Madhya Pradesh. He has completed BE at SGSITS Indore, MTech at NIT Warangal, and MS at Waterloo, Canada. He had researched for PhD at University of NSW, Sydney, Australia. After working with CRRI, MMRDA, IIT Roorkee, and DTC for 12 years, he had migrated at Australia in 1991. He has over 40 years of professional leadership, project management field, research, and teaching experience. He has acute specific knowledge and developed exercise in safety system approach, road safety management, policy, strategy and action planning, road safety audit, road safety engineering, and traffic management. Also in areas of transportation system planning, integrated transit technologies, strategic master plans, operational and project management. He has worked in 15 countries and he has trained over 500 engineers. Without further ado, now I invite Kailash Tiwari sir to take over and begin the session. The platform is yours, sir. Thank you, sir.
शुरू करो. Thank you very much for inviting me. It's a great privilege to make a presentation.
Sir, unmute yourself, sir. Yeah. Now okay, sir.
Yeah, if we quote the numbers, in last 10 years in India, 15.3 untimely deaths have occurred due to road crashes. So that is a very, very big number. And last year in 2023, young 5 to 29 years of age. So can you start the presentation, please?
Sir, start the presentation, sir. Some second.
He shares
Yeah,
the screen, sir.
Ganesh. Okay, okay. Ganesh garu. Yeah, he's sharing his screen.
Is it okay, sir?
Yeah, presentation. Go to presentation. Ganesh garu,
Sir.
make it fast. Sir is waiting.
Okay, okay. Just a minute, sir.
Sir, Sombabu sir, please help him to share the screen, sir. Any technical problem or?
Ganesh, sir. Ganesh, sir, what am I audible, sir?
So that is what we have to do. So for that purpose, because it's a concern not only in India, but also it is a concern throughout the global level. And for that purpose, they started in 2011 what we call the Decade of Action to improve the road safety. So just to start with that figures, as I mentioned, that one, that globally about 13 million people, they died in 1 year. And most of the people were 5 to 29. USA again, which is a highly developed country, there also 130,000 people, they died. In India, 1.5 millions, those fatalities and serious injuries, about 5 million. And this figure has been corrected now. It is 170, in place of 173,000, it is 178,000. And excessive speeding has been the main reason for the fatalities. Next, please. So to reduce those, prevent those fatalities, because engineers, they believe in prevention is better than cure. So what can we do? First thing, we should treat this as a system. And road safety is a shared responsibility. It is not only that like one organization or one department. So first is a safe system approach, which started about 30 years ago in Sweden. And also similarly, sustainable theory, sustainable safety in Netherlands. So they started the concept. And with that one, that they identified what we call the pillars or intervention, where if we take the action on those interventions, then we can prevent those road crashes and associated casualties. So first one is that one, what they mentioned, that one, safe roads and roadsides. Second one is that one, safe vehicle. Third one is the safe speeds. And then the fourth one is safe road users, like drivers, riders, pedestrians. So non-motorized vehicle, people who are operating that non-motorized vehicles. And then the main thing is the road safety management. So road safety management means there should be a proper understanding between the various departments. There should be coordination, there should be collaboration, and there should be cooperation. And that's why when I started first job in, I actually got an offer to work in Kerala, then Karnataka, then in Gujarat, Andhra. So we tried to do this safe system approach, and then we established road safety authority.
Sir, please unmute, sir.
There's black spot improvement. It is a reactive approach. You have to collect a lot of data, and then you have to do that identification of black spots, and then you have to do the remedial measures. Again, depending on the budget and priority, only limited those black spots can be improved. Next, please. Next, please. Yeah. So United Nations, they started Decade of Action, and they strongly favored and they recommended that we should follow the safe system approach. And then UN Decade of Action 1, which was 2011 to 2020. And the second one was, it is continuing, it is 2021 to 2030. But unfortunately, because of lack of coordination, when this UN adopted those safe system approach, they missed or forgotten the safe speed. Same thing is again in the this importance of safety, importance of speed has been neglected in the second decade of action also. And as most of you know the physics, and in physics we have a formula called kinetic energy is equal to half mv square. So more the speed, because if it is a square, then it becomes a scalar quantity, and then it becomes like a directly proportional to the square of the speed. And if you collect like all the vehicles which are involved into a collision, so in that respect, we have to calculate the kinetic energy for each and every vehicle. So more the speed, more the severe, and more the damage, and more the this and human body, they have a tolerance limit. I will come later on in that presentation. Next, please. So these were the first 5 pillars, and it was those road safety management, and that included also the institutional strengthening and capacity building. And unfortunately, that has been totally missed in most of the those organizations in India. And so hardly you will find that like a road safety engineers, anybody in India, and also that you will hardly find any college or university or institute or academy offering any diploma, degree or postgraduate degree exclusively and explicitly in road safety. So we have a drastic shortage of qualified professional. So we could solve the problem of COVID-19 because we had a quite good numbers of those doctors and nurses. And plus we had developed the vaccine. So these are just like a vaccine, 5 vaccines where we have to take care of. We have to attend, actually made the action on these interventions. Next, please. Next, please. So again, that UN Decade of Action, they mentioned that one, and they also, there was a Stockholm Declaration in 2020, where 130 countries, they signed it. And they told that they all agreed that we will follow the safe system approach. And plus we will follow that 30 kilometer per hour speed limit in the school zones and in the shared market or bazaars. So 30 kilometer per hour, and still even in Australia or America or any other countries, still they are not following that one. And I was lucky that in Kerala itself, in 2004 and 2005, at 5 schools, I could introduce that 30 kilometer per speed limits with a fluorescent signs. Next, please. So the target, what they have agreed is that one, that we should reduce, because first decade of action was a totally failure. They couldn't achieve what they wanted to, whatever the targets they had mentioned. So they come out with the decade of action second, and then they come out that by 2030, we will have 50% reduced KSI, killed or serious injured, or FSI, the fatality and serious injured. And then by 2050, we will have the 0 fatalities and those serious injuries. So that is why it is called Vision Zero, and which is possible because Oslo is that in Norway. In last 2 years, they had the 0 fatalities. I was in charge in Canberra in 2000, and we did lot of measures. First time we introduced in Australia that on the collector streets, 50 kilometer per hour, and then on school zones, 30 kilometer per hour, and then on all the roads which are actually entering into the Canberra, 80 kilometer per speed. Plus, first time we purchased 6 radars to monitor the speed. And then the result was that from 20 fatalities, it has the population of 5 lakhs. So from 20 fatalities per year, it reduced to 2 fatalities per year. So it is possible if we take the preventive measures. Next, please. So again, this is the description. You can go through that notes. Basically, that it is mentions that there are voluntary targets, and then with that one, that it has been agreed upon that all the new roads, they have to be audited properly, and they should have a 3-star level. Next, please. And then all the old roads or existing roads, they should have a 3-star ratings. So with that one, we can improve the safety. Star means there are attributes in the design and in the operation. So what is safe system approach? The first thing is road safety is a shared responsibility. It's not only the police responsibility or the professor's responsibility or the education department responsibility or health department responsibility or RTO responsibility. It is the shared responsibility where all those organizations, they have to work together and they have to solve the problems. And we established, like as I mentioned, that National Road Safety Authority in Kerala, Gujarat, and the idea was Karnataka, Telangana. That idea was that one that organizations will sit together and then they will work out what can be done. Second thing, most important thing is that one, the human body can only withstand limited forces in a crash before this results into a fatality or serious injury. So we have a limitations. We have a limited tolerance level. So if we are stuck with a higher forces, then either we will die or we will have a very serious injury. And as I told, why it occurs? Because of that kinetic energy. Because in case of any road crash, that kinetic energy, it plays a very important role. So more the kinetic energy, more the damage. And that's why that the speed is very, very critical to prevent those crashes and casualties. Then continuous improvement in vehicles, roads, and behavior will reduce fatalities and serious injuries. Now, about 4 years ago, in India, there were no 4 or 5-star those crash-rated vehicle. Tata, Mahindra, they started making those cars, and now it has become very cheap level. Like Tata Punch now is around 6 lakhs. So that type of vehicle has to be preferred. 6 airbags, safety features. So all those features are now coming into that. Previously, only the German cars, they were being preferred. And another thing which I have not mentioned in that one here is that human can make mistake. So if you are on phone, if you are fatigued, sorry, if you are distracted, even if you are drunk, you are tired, you can make mistake. So a driver can make mistake, but he should not be punished or killed only because he made the mistake. So our purpose is that we should try our best in the features in the road design and roadside features, where we can make it safer for the drivers. Next, please. Next, please. Yeah. So the purpose of that one is that one, we want to provide the road users the layers of protection. And so that is in the form of safe road, safe vehicles, safe speed, and people are around the fallible and vulnerable human in order to prevent deaths and serious injuries. Because as I mentioned, that human can make mistake, they have a certain tolerance level. So we have to provide that one, and that's why you might have seen that now more and more emphasis is being given on the high speed and high capacity roads. They are providing those double beam crash barriers. They are providing those New Jersey type of. So the main purpose of that one is that one, if we identify, just like so many buses are falling into the ditches, but if we identify those sections and if we can provide this type of features, the buses will not go and fall into the ditches, and so many lives will be saved. Speeding, like again, same thing is that one that already in India, lucky, we have that conspicuous marking tapes on the vehicles. But there many accidents are taking place where that truck or bus is parked on the side of the road, and speeding vehicles, they are going, and then they are 4 or 5 people are dying. Another thing is the overloading. People, they do like in most of the cars, there will be in place of 4 or 5 people, there will be 7 to 8 people, sometimes 10 people. And naturally that hardly anybody will be wearing seat belts. 50% of the those two-wheelers who have died in the road accidents, 50% of those, about 52,000, 54,000, they were not wearing helmet. So these are some of the statistics we have to keep in mind, and we can prevent all those type of things. Next, please. So traditional approach has been that if there are accidents, we just say that it is the numbers. But now we classify them in fatality and serious injuries. Again, the definition of fatality as per the Indian Road Congress, if anybody dies within 30 days, then it is a fatality. And most of the police, what they are reporting, they are just mentioning that one that on the spot, if somebody has died or FIR, it is mentioned, then only they record. Otherwise, they don't follow it up. Whereas in the Western countries, they follow it till the person is admitted in hospital, insurance claims. So from all other sources, they collect that one. Then human factors, as I mentioned, that one humans make mistakes and humans are fragile. Again, we have to consider as a system designer. Like in Andhra, I did road safety audit of 22 roads. And when it was about to open, and when we inquired, was mentioned that some other department will put sign and marking on that road. So roads were opened, people found that there is no sign and marking, and people started speeding, and within one month itself, fatality increased by 50%. So the coordination among the departments is very, very important. And people don't want safety, but people want safety. The main problem with these road fatalities is that it is separated in time and space. Daily 500 people are dying in India, but they are actually distributed in time and space. Somebody is in Hyderabad, somebody in Chennai, somebody is in Mumbai. And again, the timings are different. Somebody 2 o'clock, somebody 4 o'clock. And politicians, just if there is a major accident, more people die, then they will give 2 lakhs to 5 lakhs. And you will be wondering that we did a detailed cost analysis. The estimated cost of a average cost is 91 lakhs rupees for a fatality in India. So people go for mileage when they want to buy the cars, that कितना देती है, या मतलब कितना इसमें फ्यूल कम से कम मतलब फ्यूल पे खर्चा होगा. So they want to just bother about that. They don't bother that the cost of a fatality is 91 lakhs. So you can imagine that one, that it is the importance only recently now that when the Tata and Mahindra, they started making cars, some emphasis is being given on that. So our aim is eliminate fatalities and serious injuries. Previously, that all the designs was to maximize the capacity. Safety was totally ignored. Next, please. So as I mentioned, those performance indicators at the global level. Yeah, next, please. So these two performance indicators has been agreed, and where that our minister, Mr. Gadkari, he has signed in Stockholm Declaration and also in other forums, that all the roads which will be constructed in India, they will have a recognized standard, and that will be the 3-star. And then similarly, when that they improve the existing roads, it should be meeting that 3-star. 75% of the roads should meet 3-star. And again, so road safety audit, when they conduct the road safety audit, they should keep in mind that all the features according to the 3-star levels, they should be there. Next, please. So what works actually, based on the detailed study in many countries, the WHO and World Bank, they have found that one, that which is the most effective, which can at least reduce or prevent 30% of those fatalities. And as usual, it is like a common sense, but they have scientific and evidence-based data which they have collected, and they have mentioned that one, that first thing is a safe mode of transport, integrated public transport. So that is very, very important. Like I was a general manager of DTC, Delhi Transport Corporation, for almost 4 years. We were running 5,000 buses. And and Delhi, they were traveling about 5.6 lakhs, 56 lakhs trips. But not a single passenger who was traveling was ever injured or killed. So safe mode of transport is very, very important. More that it is a, you can say segregated, like BRT, metro, light rail, the more the better it will be safe mode of transport. And also it will be efficient mode of transport. It is also the cheaper mode of transport. Generalized cost will always be less for the safe mode of transport. If it is a properly planned and properly designed, that is the case. But many of the BRTs in India, they are failing because they have not been designed properly. Second is that one barrier system. As I mentioned, that human make mistake. So if you can provide the more and more, identify the locations, if there is a ditch or if there is any object which you cannot remove, you cannot shield, you cannot delineate, so then in that case, the barrier systems, and now wire barriers, they are getting very, very popular in Australia and New Zealand. So those wire barriers, they are more sustainable, less those amount of money, less cost, and at the same time that they are highly effective. Then third one is the medians. Medians, another thing is there, coming to the speed. If at the speed of 30 kilometers per hour, any pedestrian actually has the collision, then out of 10, one person will die. If it is a 90, if it is a 70 speed, then all 10 people will die. Same thing if it is a person goes out of that like a runaway, or that leaves the road and then collides with a pole or that tree. So in that case, the person will die if it is if he was traveling at 50 km/h. Then same thing is a 70 km if there is any head-on collision, that the person will die. So these are the type of things which is very well researched and which we have to keep in mind. Roundabouts, again, roundabouts are very, very popular, and not only popular, it is very safe also, because in place number of conflict points reduces, and also that it is a more of a merging and diverging rather than head-on collision. Then if the money allows, then grade separation, reducing the risk of those intersections. Again, intersection design is very, very important. So especially that if you see that Y intersection and T intersections, so T intersections are always safer than the Y intersections. Then pedestrian footpath means our aim is to always segregate. And then pedestrian crossing. So anybody goes on the road, they should treat that it is like a war zone. Maximum casualties of the pedestrians occurs when they are crossing the road, because they cross at not at a proper location. Even if they cross, they don't see both sides. So always from the grade 1 in Australia, they teach that you stop, look, think, and then cross. So that type of curriculum has to be developed from the grade 1 itself, because if that person is same thing, if you teach a person at the age of say 5, 6, the person will follow it. But if you teach the person anything on the road awareness or techniques, so after a certain age, they don't follow it, or they become overconfident. So that's why the behavior improvement is not there in these points, because behavior improvement, and now more and more people, they say awareness, behavior, but it has been proven by many those researchers, and many documents are there that they mention that that main thing is we should have a solid action where we can do something, what we call the like a traffic calming, what we call the that a sleeping policeman. So if we provide the features on the road, then we can actually reduce the speed, we can manage the speed. And incidentally, when I was teaching at Roorkee University, after 2 years of research, I developed the standard, and which I submitted to IRC, and IRC approved it. That is IRC 99 in 1988. There was too much resistance. The people said like even Dr. Justo, he said that roads are for mobility. But I insisted that if we have to provide the location warrants, then we have to have the proper shape and proper size and proper signage. And in Hyderabad, in Roorkee, in Ahmedabad, I found that when speed breakers have not been constructed properly, there were shops for axle repairs next to them. So that is what we have to do. That is still many of the engineers They don't know there is a IRC 99 which gives all the specification. Even that Bengaluru or the Karnataka, that specification for the roads, they have mentioned that it should be 2.7 meters, whereas it should be 3.7 meters. And also in many other places, still there is a lot of confusion. Then raised intersections. So it is not only that like a pedestrian crossing, but most of the schools are busy areas. We have to put that raised crossings or raised intersections. So people get the feeling and they reduce the speed. Gateway treatment, like the moment you enter into any town or city, the speed will be mentioned, as well as that big signs will be provided. Lower speed limits, as I mentioned, that 30 kilometer per hour. And now it has been already agreed by 130 countries. And slowly now it is being provided. And then the most important thing is enforcement. Because unless you provide the enforcement, but enforcement has to come only after you provide the facilities. If you provide that geometric designs as per that speed, and then you educate the people, and then you use the speed cameras. And in the speed cameras, there are a lot of now development which can be actually there. The latest one is that what we call the average speed, because people, they know where is the fixed radar cameras. So they slow down there and again they go fast. If there is a police is standing with the camera, and now there an instrument also, you can detect where is the speed camera. So now they are doing what we call the average speed cameras. So for a 20 kilometer section, whatever is the speed is there, depending on the distance, one can take the photograph before entering, and then one can take the photograph after entering, and then one can do that automatic with the proof, the challan system. Seat belt, very important. Helmet, very important. And if the seat belts and those, again, it is the user's discretion. It's not that that somebody has to force upon. Motor Vehicle Act was passed in 2019 in India. The first state which refused to obey it was the BJP-led government in Gujarat. They told for 1 year there is no need to wear helmet in Ahmedabad. So these type of politicians, they make such decisions. So political decisions, again, for simple popularity, they are not desirable. Vehicles, seat belts, electronic stability control, advanced vehicle technologies, and from 1st July 2024, in entire Europe, all the new cars will be fitted, already started that one, will be fitted with what we call the ISA, Intelligent Speed Adaptation System. And with that one, that nobody can go beyond the speed limit. So that will be very effective if it is introduced in India. Next, please. Another, like based on the research, the signs are one of the most effective, because as I think you might have read, everybody, that signs are the one which we use as a road engineer to warn the drivers, to guide the drivers, to regulate the drivers. So signs and marking, they are very, very important, and that out of that one, signs are very, very important. We inform the drivers. So again, they have found that one, that what is the benefit cost ratio? Because simply we cannot put any engineering solution or any measures until unless we have again the proven evidence, and then we have that those benefit cost ratio favorable. Next, please. Next, please. So again, this is the example of Victoria, Australia, that how they have tackled the problem. And so from like 1970, about 1400 fatalities per year. Now it has reduced about 200 per year in 2024. Raju, so they have taken various measures. Like first, Australia was the first which has introduced the seat belt. Then they introduced that breath test for drink and driving. Then focus was on speed management. And speed management, if anybody exceeds by 50 kilometer speed limit, then there will be $600 fine, and 6 points will be deducted. So total 12 points are allowed per year for any driver. If anybody jumps a red light, 3 points. So if four times anybody jump the red light, means license will be gone. In Dubai, if any truck driver or bus driver jumps the red light, they will be deporting after 2 times. So these are the type of strict measures are also there. And one of the, next please. So one of the very important aspect is there is a Australia, each and every state has got the Minister of Road Safety with the Office of Road Safety, with the professionals working on road safety. And then on the central government also there is a Minister of Road Safety, which is totally missing in India, in spite of those 15.3 million people, 15.3 lakhs people dying in last 10 years. So then appoint cabinet level road safety ministers, review road safety strategies, commit to a minimum $3 billion for road safety fund, set an extended vision zero target, establish and commit key performance indicators, implement rapidly proven vehicle safety technologies. Australia, more than 96% of the vehicles are 5-star. So whenever anybody decides any fleet vehicles, there is a condition that there should be always be 5-star rated. And unfortunately, like Scorpio Mahindra was actually introduced in Australia, and when it was tested, it was found to be 0-star. So it's a very, very there that it's a very, very strict rules and regulations, and they follow it very seriously. And road safety audit, it started with the UK, but later on that Australia and New Zealand, they adopted it. And then one of my Australian colleagues, he developed that road safety audit manual for India. So road safety audit, now a lot of institutions, they are actually conducting those courses, 2 weeks certificate courses. But unfortunately, road safety audit is a qualitative process. It is just simple audit, tick mark, checklist, and you provide some recommendations. So it is not the one which is expected from the road safety audit. It should be proper quantified, those whatever measures are required, benefit cost ratio has to be calculated, and then it should be implemented well in time. So road safety audit, and many people are now doing that course. They think that they have become expert. But the main problem is that one with the road safety audit, as I mentioned, it is a qualitative process. And again, that knowledge of entire, like a comprehensive knowledge of road safety is very, very important for the different road users. What are their characteristics? What are their features required for their safety? So all those things are again very, very important. Next, please. So again, the importance of safety, as I mentioned, that one is speed, which is unfortunately when the super expressways were designed for Indian conditions. I don't know who did it or who advised that design speed of the super expressway should be 150 kilometers per hour. So as you can see that because 95% of our vehicles, they are 0 to 3 star. 30%, as admitted our minister, Mr. Gadkari, 30% they have no license, plus overloading, plus fatigue driver, vehicle conditions. So with that one, even 120 kilometer per hour operating speed is very, very dangerous. And that is the reason that 72% of the deaths, they are occurring on our roads. So we have to be very, very actually, and now realizing that one, that speed kills. On the Yamuna Expressway, somebody took a wise decision, and now they have reduced that from 120, they have reduced it to 75 kilometers per hour. And that's too because of that, the reason they have given is the fog. Because whosoever is looking after, or whosoever is in charge for the performance, because a road accident or road crash is also a crime. Legally, it is a crime in India. And the purpose of that one, that if it is more crash, more accidents, more casualties, then it will reflect the performance of the in charge. So somehow somebody took a bold decision, and now from 15th of December to 15th of February, the speed will be reduced to 75 kilometers per hour. Madras High Court, after a lot of review, they did and mentioned that throughout India, on all expressways and on national highways, the speed limit should be 80 kilometers per hour. And they have considered all the aspects, like as I mentioned, vehicle conditions, vehicles rating, driver conditions, and the historical data. So with that one, but unfortunately, it was challenged in the Supreme Court. And recently, Supreme Court mentioned that the High Court has no rights. It is out of their jurisdiction to reduce the speed or to make any recommendations on the speed. So speed remains, design speed as 150 and then operating speed as 120. And the result is daily like 72% of the people, they are dying because of the overspeed. So crash type is mentioned that if it is any crash which is more than impact speed is 75 in head-on, that is the level where that risk of deaths escalates. Side impact, the intersection design, So that's why more and more it is preferred to have roundabouts. Side impact with tree 30 kmph, and for pedestrian or that in the market area 30 km/h, or in the work zone where the people are working. So this is very, very important to understand. Next, please. So again, safe speed, as I mentioned, that it is very, very important. And then all initiatives should be taken to reduce the speed of travel. Next, please. So again, there is a relationship, as I mentioned, that one first is the engineering, that road are to be designed with all the safety features. Then there should be education, and then there should be enforcement, and then there should be monitoring and evaluation. So it's like a continuous process of before and after. Next, please. So road design, I think most of you people might be, I think that you are engineers, and very, very important role for the engineers is there. And unfortunately, when I was teaching at Indore or Indore University or at Roorkee University, I found that in the BE course, out of say around 40 to 50 courses, subjects, there was only one subject which was highway engineering. And in highway engineering, again, out of 12 chapters, one chapter was a traffic engineering. So most of the engineers, because they are more interested in analytical, so they used to skip that one. And they used to become like a civil engineer. And this is a harsh fact that, and they have passed, like they have got the degrees, but they don't know what is a regulatory sign, what is a warning sign, what is the meaning of sign. And unfortunately, in India, many of them people, they don't drive. Even if they drive, they will have the driver with them. So to understand that one, that what are the traffic control devices, what are the traffic calming devices, how to use them, they hardly actually aware of those things. So it is my request that everybody, that to be safer side, please go through that IRC 99, and now it has been revised to in 2017. And there you will get the idea that why we should do the speed management and speed control. Next, please. So these are what we call the traffic calming devices. We actually, engineers, we can provide what we call the sleeping policeman. So if we can provide those features, then we can actually do the speed management. So it is consist of horizontal, vertical, lane narrowing, roadside development, which are self-enforcing physical or psycho perception means to produce the desired effect. Next, please. So just some examples are there, like a roundabout, raised pedestrian crossing. Then you are using also the different colors. So to make highlight, you are marking on the pavement. Then you are like putting sometime lights also. For bus bay, you are putting that bus lane and bus bay, different colors of the pavement. So these are the different measures, and again, details are there in the IRC 99, which are dealing with that speed management devices. Next, please. So again, like as you see that raised speed humps and markings, again the speed that this is what I designed at that time, which was 3.7 meters long, 10 centimeter height, and another one where that buses and trucks are more in numbers. There it was 5.5 meters parabolic shape, and then signs, and also it is an advanced sign and plus warning that it is you have to follow that speed hump. This is Australian situation at 20 miles per hour. So if you more you go higher speed, and recently if you might have read that one, that a case of Dehradun where that girl video became viral. So that girl was on a scooty and she totally lost control. And I think there was another one in where the car jumped. So you will find, and more than 5,000 people die in India only because of the wrong design of the speed humps. And even today, when I was working actually on World Bank project in Gujarat, they are still using the term in place of speed hump, they are putting speed bump. Bump is a derogatory word, and that's why we avoided when we prepared that IRC that 99. But throughout Gujarat, still you will find that sign says that is speed bump. Next, please. Again, that speed, it is a very simple device where it can be mentioned that one, whatever is the maximum speed. And next one, please. Yeah, again, this is at the school zones or at other places. It is again mounted with a camera, and school speed limit is 30 kilometers per hour. If anybody goes beyond 30, then the photos will be taken and that the person will be prosecuted, and whatever fund they raise it, that is being used for preparing and procuring more of this type of signs. Next, please. So this is another thing which is I have not found actually in India, but I have been told that now they are being introduced. This is what we call the dynamic speed sign. The same sign, speed sign, can have the speed limit from 40 to 120. So depending on the traffic conditions, depending on the weather conditions, so same sign will be showing different speed limits. And this is what we call the dynamic speed system. And this is has to be introduced on especially on all our high speed and high capacity routes. If any work is going on, that lane can be shown that it is closed. If it is a diversion is there, then it can be mentioned that merge right, merge left. So like that one that is there, which is a very, very important. And even in Abu Dhabi, this type of signs, or Dubai, this type of signs are not there. But this is the one which is highly preferable in case of India when we are constructing those high-speed roads. Another thing is very, very important, which we can use that one, as I mentioned, that one, audio tactile line marking, which I think recently only some 50 to 100 kilometers it has been installed in Nagpur Expressway. So the idea is that one, that the moment you are distracted or impaired or fatigued or on mobile phone, the moment you go on the edge line, you will feel that vibration, and also you will feel that sound. So when the moment you go and then you are alerted to that one, and if anybody has gone to that overseas and has driven or had been in the cars, this is very, very highly effective. Already we are putting the marking. Here we provide the rumble strips on those line marking, edge line markings. Even in central median, now in South Australia, they don't make median. On the 1 meter apart, they provide the two audio-tactile line marking to avoid those head-on collisions. And there that glare is an issue, but because most of the cars now which are being sold in Australia, they have automatic that sensors which can, if there is anybody coming with a high beam, it can actually warn and it can dip that lights. So the anybody coming from the front about 500 meters to 1 kilometer, then automatically it will lower the, like go to from high beam to low beam. So there is no glare in that case. So they are very, very highly effective and very cost effective also. And plus also there is, so for the miles to miles, this is very, very effective. Next, please. Then as I mentioned that one, education is very, very important. The risk of involvement in a fatal crash doubles with every 5 kilometer per hour increase in speed over the limit in a 60 kilometer per zone. So this is very, very important that one has to understand the importance of a speed, and also that how it impacts the number of casualties. Another thing, very, very, very important thing, if you design a vehicle, design or operating a speed, if you keep 80 kilometer per hour, and in place of if you have 120 kmph on that highway, more than 50% of the fuel is consumed. And more than 50% consumed means air pollution increases by more than 50%. So if anybody is a environmental background, this is the best and simplest way to reduce the air pollution. Just simply reduce the speed. Simply reduce the imported fuel what we are spending, because each and every vehicle is being designed with the optimum fuel consumption of 70 to 80 kilometer per hour. So if we are going for a more, anybody with a mechanical engineering background, they must understand that one, and they must be knowing it very well, that there is an optimum fuel consumption. So going for a high speed, stopping side distance increases, pollution increases, air pollution increases, noise pollution increases, your fuel consumption increases, trauma to the family increases, and then additional burden on the emergency services increases, additional burden on the 30% burden on the hospital sector increases. So there is a simply just if you can manage the speed properly, if you can reduce the speed, and that is a very simple, just change the board and enforce it. So rather than doing this thing, that thing, that is what we have to do it. And that is the need of the hours today. Next, please. Again, as I mentioned, that enforcement is very, very important. Use of ICT, intelligent transport systems, that we have to adopt, and that the best about 10% of that fatalities or road crashes can be reduced simply by police patrolling. Even if you put a cutout, that itself makes the difference. Installing CCTV, fixed speed cameras, mobile speed cameras, point-to-point speed cameras, and average speed cameras. And these are to be used as a deterrence, not as a cash cow. Many of the countries or many of the states or police department, they are using that radars as a cash cow, because all the revenue, whatever is coming, that is all going to the general revenue. They are hardly being used for the improvement of safety. So that is, again, we have to create awareness that it is not for enforcement, real enforcement, but it is a general deterrence. So a police can catch anybody anywhere, and if anybody is not following those speeds. Next, please. So measures taken worldwide, what has been done in different countries. So first thing is that TRL study, that London study has found that 10% of the crashes can be actually reduced and prevented by police patrolling. Then in Brazil, they have reduced that speed limit from 90 to 70, and there was a reduction of 21.7%. In Bristol, they reduced by 63%, and Netherlands reduced from 35,000 to 661. And now Autobahn, which is always being given example in Germany, they have also reduced the speed limit to 130 kilometers per hour. So it is the time for India to look into the setting safe speed limits and adopting the safe system approach. And by doing this, India will join the countries that have achieved the greatest reduction in fatalities recorded over the last 20 years. Next, please. Thank you. Be visible, be safe. Again, that loss and suffering associated with road traffic deaths and injuries are preventable. So as I mentioned, that one, if you do the intervention properly, then, and we follow the safe system approach with some modification, because we cannot just copy that what other countries have done, because we have mixed traffic conditions. We have many of those two-wheelers, but at the same time, like in Indonesia, they have the segregated those roads for the two-wheelers. So those type of situation we have to also create as per our, that one, roads are not only for vehicles, but also for the human being. Thank you.
Yeah, thank you very much, sir. Dr. Kailash, sir. You have thrown some light on the road safety, which is very useful and relevant to the theme of our FDP. And we are delighted to have you in this session, sir. Though you have been recovered recently from your ill health, we are very much thankful to you for joining today itself. Yesterday you are suffering with some health problem, but still you have joined here today to deliver the lecture. Thank you very much, sir. And really, it is a very highly knowledgeable and thought-provoking session, sir. And it resembles your vast experience in the field. And really, all our participants will definitely gain knowledge in this road safety, which is also one of the disaster, upcoming disaster, urban areas specifically. And also participants should know that we are trying to bring out different sectors of disasters, and definitely our Kailash sir lecture is something different kind of dimension being delivered. And sir, with your permission, let me ask you one or two questions, sir.
Yeah. Just before you are mentioning,
Sir.
You might have covered many topics on disaster,
Yes, yes, sir.
but anybody can you can understand the gravity
Yes, sir.
and the seriousness that 15.3 lakhs people,
Yeah.
they died in last
Correct.
10 years in India, and
Yes,
that
sir.
is untimely.
Yes, sir.
Most of them are breadwinners, male people,
Yes, sir.
and the result is that trauma to their family. Breadwinners has gone.
Yes, sir.
So if a breadwinner has gone,
Entire family will be disturbed, sir.
yeah, so it is the one of the biggest a disaster, even more than the COVID. And
Yes, sir.
unfortunately, that the thing is that we don't have any qualified professionals in this area.
Yes, sir.
None of the college, university, IIT, REC, NIT academies, they are offering any diploma, degree, or postgraduate degree in especially on road safety.
Yes, sir. Yes,
Some
sir.
people, they have done the PhDs,
Yes, sir.
and they think that just by doing a thesis, its knowledge is enough.
Yes, sir.
And not only that, it is the practice in India, but Australia, New Zealand, America, and they are all suffering.
Yes, sir. Sir, yeah, with this mindset only, I am asking very silly question, which may be very primitive and which may lack technical technology and all. So why don't we reduce the speed in the manufacturing itself, sir? Because the companies are producing vehicles with more than 120 or 200 kilometer speed. But why can't you stop them, or why can't we limit them at the manufacturing level itself? And why to impose the speed limit and all?
See, that's why that the European always take the lead.
Yes, sir.
And as I told that the fatality rate per lakh population in Norway, Sweden, European countries is about 2 to 5
Yes, sir.
per lakhs people.
Okay.
And they have again taken the lead. And as I already mentioned, that one, they tried all the mechanism and all the measures. And now they have made it mandatory
Yes, sir.
that from 1st July 2024, each and every vehicle will be fitted with a system
Sir.
which will be GPS connected, as well as which cannot be actually changed.
Yes,
That
sir.
whatever it will read the sign, it will again compare with the Google, and
Okay.
then vehicle cannot be actually go beyond that speed.
Okay.
So that type of mechanism will have to be introduced in India also, and it will be introduced in, because we take some time to do that one. And plus again, these manufacturers,
Yes,
like the highest selling company of cars in India is a Maruti Suzuki.
yes, sir.
And Maruti Suzuki has first time a vehicle called Desire, which has got the 5-star rating.
Okay.
So out of those, all the vehicles, whatever is being sold in the market, are by Toyota or by Innova, or except Volkswagen,
Sir.
Mahindra, and Toyota, which are made in India, none of them vehicles are 5-star. Plus, those vehicles which are claimed to be the 5-star, they have also the different two categories. One is for child safety and one is for adult safety. So
Yes, sir.
even the Tata Nexon is not 5-star for the children.
Yes, sir.
So again, this is important. And now that the government of India has started, they will test themselves. But just to please the reality is that one, just to please the manufacturers,
Yes,
they
sir.
have lowered down all the standards.
Yes,
So
sir.
even if it will be 5-star from the Bharat NCAP, it will be actually 0 to 3-star. And as I gave the example of Scorpio, which
Okay.
was tested in Australia to the strict condition, it got 0-star. and everybody feels that Scorpio is very, very safe, and it has got a very good rating in India. So we have to provide those features, but the main thing is that one, even if there is a speed, it is the operator.
Yes, sir.
Yeah, the operator has to be conscious. How many people have, I think today, knew that that cost of a estimated cost of a fatality is 91 lakhs rupees.
Yes, sir. Okay, sir. Sir, and also nowadays we are able to see some on the highways, some black spots, some marks are some identification marks are given on the roadside. What are these, sir? What are these black spots?
See that normally what we do is actually in Western countries, if it is a speed is there, if suppose it is a 120 kilometer per hour.
Okay.
So 120 kilometer at the speed of 120 kilometer per hour, depending on the speed of travel, we provide additional marking
Okay.
on the road itself, that you have to maintain this much gap, because normally 2 seconds of gap is required. And in like Western countries, wherever there is a black spots, they provide like a black this cross,
Yes, sir.
and they write also that it is a, how many people have died. If it is injured, then red those. So somebody might have copied it and then tried to introduce in India also.
Yes, sir. Right, sir. Right, sir. Thank you very much, sir. Participants, if you have any questions, please ask.
Sir, myself, Kiran
Yes.
Kumar, sir.
Yeah. Go ahead, sir.
Sir, the maximum posted speed limit in urban is 30 to 40 km/h, sir, in India condition. In rural roads, 60 to 70 km/h, sir. But the driver choose more than this posted speed limit, sir. So it will affect on the accidents and everything, sir. That is collision between vehicle to vehicle or vehicle to pedestrians. So which type of measures generally we are taken in that case?
See, as I mentioned, that one IRC 99, that deals with all the types of physical features which you can provide. Unfortunately, or fortunately, you can say that government of India, even if there is a situation warrants, they took a decision that on national highways and those expressways, there should not be any speed breakers or speed humps.
Yes, sir.
So that is the type of thing they have mentioned already. But you can always, depending on the type of road, you can always provide, like there are about 10 types of those speed control devices. What we call the chicken is there, then we have humps, then we have raised humps. Again, these raised humps can be designed for 40 kilometer per hour, 60 kilometer per hour. Only thing you have to provide the proper width and those shapes and size. So it is possible to do that type of thing. Narrowing of the road, that type of things can be done. Again, that road can be restricted, like a what we from old tradition, like trucks are banned in particular roads, cars are banned in particular roads, two-wheelers are banned. So all sort of, the only thing is that one has to take the initiative.
Yes, sir.
And it is possible, because we have, like I used to, when I was teaching at Roorkee University, and Satish Chandra was my student, who became the director of CRRI.
Yes, sir.
So at that time, I told all my students that as a system designer, just like Lord Rama, we have all sort of weapons in our arsenal. Depending on the problem, we have to attack and solve the problem. So this is the job of a experienced and qualified engineer. So we can tackle all sort of problems if we have the proper knowledge, proper experience, and will to do it. And it is very easy to convince the authorities if you are coming with that type of solution.
Okay.
Okay, sir. Thank you very much, sir. Actually, for a long 1.5 hour session, you have given without any break. Really, we wonder about your energy levels and the commitment and your dedication, sir. Thank you so much, sir. Thank you so much, sir.
Sir,
And,
Okay,
one
thank
question.
you.
and
Any question?
Sir,
Tiwari,
sir, sorry to interrupt, sir. One
Yeah,
small question from my side, sir.
yeah.
Sir, how can we effectively monitor and evaluate the impact of the speed management intervention? Several programs are there in our India. How can we monitor them, sir, whether they are actually achieving their desired outcomes or not? Like road safety audits are there, sir, but it is merely a checklist, and small recommendations will be given, which won't be given that much priority. Sir, are there any other alternatives, sir, to that?
See, the first thing is I think what we need is a what we call the safe system approach, which is a quantitative approach. And in the quantitative approach, we give that weightage to the different deficiencies. And more the deficiencies, we identify them, and that is now very popular in Australia and New Zealand. And they have taken the lead. So if you do the research, safe system approach, and they have combined road safety audit with the safe system approach. So where that both the quantitative and qualitative approaches, they have developed those entire techniques, and it is not something rocket science. It's just like checklist, but with quantification. And like Hyderabad, I did for 22 roads road safety audit. And in that road safety audit, when we did, I was the one who first introduced road safety audit concept in 2003, 2004 in Hyderabad. And I developed the manual for road safety audit, black spot improvement for Andhra and Kerala. So there, the main emphasis was that one, that we should be able to identify, we should be able to take the preventive measures. But at that time, this quantitative issues were not there. But because it was a World Bank study, and we wanted to actually improve the safety. So we calculated the BOQ, we got it designed, and then we got the funding and it was implemented. So that is the approach one should do it. In a road safety audit, you provide the recommendation and then you just leave it to the client. So it is the client duty to get it designed, prepare the bill of quantity, and then get the funding and get the implementation, which is usually hardly it is being done in India. But that is the proper procedure.
Thank you, sir.
Sir, may I, sir? Because yesterday you were not well, Tiwari, but if you permit me,
Yeah.
it was a nice presentation, sir. Thank you so much for the presentation. And in one of the slides, you have projected about the fatality or loss of life and the different types of collisions and the speed limits.
Yeah.
In that, first one is the head-on collision, 70 kmph. Then collision at right angles, it is 50 kilometers per hour. And then when a tree is hit by a vehicle in this site, it is given as 30 kilometers per hour. But physically, when we think, we feel that it is like a kind of rubbing action or something like that when a tree is hit from side. Compared to that, 90 degrees collision would cause more damage. That's what we are feeling. And could you please clarify, sir?
Yeah, see, the thing is that one, I think, recent case, if you see in India itself, this accident of Mr. Mistry. So when that they wanted to change the lane, a highly experienced driver. The doctor was there, she was driving, and she could not actually go to from third lane to second lane. And she tried to slow down, but she collided with, the car was collided with a concrete wall. So in that case, it was definitely that there was no marking or delineators on those concrete wall. So that is the type of thing. And also, if you remember anybody who is a cricket fan, there was a player, all-rounder of Australia. I don't remember his name, but he was a Aborigine person, and I think that Harbhajan Singh told him monkey. And he took some 2 or 3 beer drinks. 3 beers are allowed in Australia, and then you can drive. And he was going on the road, and he got distracted, or he couldn't control that vehicle, and he collided with a tree and he died on the spot. So there are many such cases. Then there was I think Manvendra Singh's wife, driver slept for a moment, and car went about more than 200 meters and then collided with an object, and that wife died. So in that case, that the best actually the remedy and most effective one, as I mentioned, that one, to provide that audio tactile line. And it's a simple, just a rumble strip on the edge line. So we should see, we need not reinvent the wheel. Whatever has been tried and tested in other countries, like Bangladesh, I was involved into when Sheikh Hasina was also there. So I was advising to the Bangladesh government to how to prevent and reduce accidents. And we could convince the authorities, and then they decided that entire Bangladesh, that speed limit will not be, maximum speed limit will not be more than 80 kilometers per hour. In Australia, that maximum speed limit is 110 per hour. In England, it is 112 kilometer per hour. But somehow somebody has announced or advised the minister and authorities, and we are going for that 150 kilometer per hour and 120 as a operating speed.
Right, sir. Thank you, sir.
Thank you, sir.
Coordinator, can you please conclude with a vote of thanks?
Yes, sir. It is my privilege to deliver the vote of thanks for this insightful FDP on integrated speed management approach to improve road safety. On behalf of Ramchandra College of Engineering, I extended my heartfelt gratitude to our esteemed resource person, Dr. Tiwari, for sharing valuable insights and expertise on speed management and road safety. You thought provoking session in truly enlightening. Thank you once again, sir, for your sharing your knowledge and expertise with us. We look forward to future opportunities to learn from you, sir. And let us carry forward this learning and to enhance road safety in our communities, sir. Thank you once again for your valuable time and contribute, sir.
So definitely it is a privilege for me, and thanks for inviting me. And fortunately, I had been in India, so it has become more easier for me. Thank you.
Thank you, sir. Thank you so much.
So participants can use the feedback link. Thank you, sir. Tiwari, sir. Good night, sir.